Okay, hi everyone. My name is Husnain. Today I'll be giving you an introduction about set theory. I'm not that good in maths, but I'll try my best. As if you all remember, I guess in 12th standard we took set theory, if many of you had. Okay, it's really simple. There is nothing much to it. Okay, first, can you hear me?
Yeah, you are
Am I
audible.
clear?
Just
Okay.
try to speak a little bit clearly so that everyone can understand. Okay.
Okay.
All right. Thank you.
Yeah.
Okay.
Everyone else, I request you please mute your mic. Thank you. So that there is no disturbance in between whenever she's speaking or telling us something. Okay. Everyone, please mute your mic. Thank you. Everyone other than Husna, please mute your mic.
Okay. First, I'm going to take introduction about set theory. It's a branch of mathematics, as we all know. The importance of set theory is that used for the foundation of relations of functions, sequence, geometry, probability theory, etc. The study of set has many applications in logic physics, physiology, etc. It was developed by a German mathematician, Georg Cantor. He first encountered sets while working on trigonometric series. In this unit, we're going to take all learn about set theory, and all the stuff. Okay. First thing, we need to know what is set. Set is a collection of objects, and these objects are known as elements or members. The collection of these elements and members give us set. Sets are represented in two forms: roster or tabular form. In roster or tabular form, the elements are set between two curved braces, and the elements in each are separated by a comma, as you can see here in example A. Set A is 1, 2, 3. They're separated by commas, and they're represented. They are kept inside a brace. These are curved braces. Okay. The other example, so the set of all natural numbers. If one write the set of all natural numbers which are divisible by 42, divided by 42. As
Shubham, please mute your mic. Shubham Kumar Mishra, mute your mic. Thank you.
7, 14, 21, and 42. This is how we represent a set in a tabular or roster form. Okay. Very easy. Just curly braces, and inside each set should be separated by a comma. That's the main thing. You can't just write the numbers or the elements inside without commas between them to know that this is a separate element. Now in set builder form, all the elements are of a set possess a single common property. Like you can see in example, V is equal to, we write a brace here, X is a positive integer and X is less than 20. It's represented like that. Then we can write what is X less than 20. What all the numbers are less than 20. That will start from 1, 2, 3, 4 till we go to 20. This is how we represent sets. As we said, what is set? Set is a collection of objects, and these objects are known as elements or members. Okay, and sets can be represented in two forms: roster or tabular form. That is, the elements are separated by commas and they are enclosed in curly braces. And the second is set builder form, where all the elements of a set possess a single common property. They all have the same common property. Okay, that's all about sets. Is it clear?
Yeah, I think you have done good. Now please go ahead.
Okay. Next is set membership. There is nothing really much about it. It's that we need to know what element is present in that set. Like, just give me a second. Okay. If an object is in the set, it belongs to that particular set. As we know here, in first here example, in example 1, 2, 3, we know 1 belongs to set A, right? So we'll say that 1 is an element of A. How we write that? We write here, as you can see here. We said here capital A and small a. Here small a is the element in the set capital A. So we write A is the element of capital A. Small a is element of capital A. Here I wrote it here as E because I can't find that symbol, but the symbol is so similar to A. I can show you here even the actual symbol. Let me use it. Yeah, here. 3 is element of P. Means we know that 3 is an object or is a member or is the element present in set P, capital P. Okay. And if this element is not present in the set, we say this element doesn't belong to set P or it's not there in set P. So it's here, like 15 is not an element of P. The same like we wrote E, but we cross it. 15 is not an element of P. Got it? Now properties of a set. While writing sets, the order does not matter and repetition of elements is not allowed. Like here, if we have a set, let's go back to the example, 1, 2, 3. If I want to write another, like if I have this same set A 1, 2, 3, I cannot write 1, 2, 3, 3. I can't repeat the same element 3 or 2 or 1 again. But I can change the order. I can write 3, 2, 1 or 2, 1, 3. It doesn't matter. It's the same set. So the order in the set, it doesn't matter. But repetition is not allowed. We can't repeat the same element twice. Okay. Now cardinality of a set. So simple. It's just the number of the elements in the particular set. And it's represented by here, right?
That is called a modulus.
Yeah.
Modulus of X.
Yeah, modulus. Yeah, modulus of, no, it's cardinality of a set.
I mean,
right?
Yeah, it is cardinality. I mean to say that this is modulus X.
You mean this hashtags, right? Like this lines.
The representation.
Yeah, that's modulus.
Yeah.
Yeah, the representation as modulus. Okay. For example, we have in set A, the elements are 7, 8, 9. The cardinality is that the number of how many elements there inside. There are 3, so we write it like this. Cardinality of set A is equal to 3. Now empty set. Empty set is nothing that there is no, a set is empty, void, it have nothing. That's known as empty set. I'm going to show you how it's represented here. I can't show it, but I'll show you here. This is how we represent empty set. Can you see it? I highlighted it. This is how we represent an empty set. Null set. In this set, it's empty. There is nothing in that set. Like for example, we have P, where X is an element of 1, which is less than X and less than 2 is a real number. We need a number which is less than 1 and greater than 2. You know, there is no such number which is less than 1 and greater than 2 because these two numbers are coming after each other. So this is an empty set. We have it as an empty set, the result. The same thing, let R, where X is an even prime number greater than 2. You know, there is no even prime number that is greater than 2. So it's a empty set. Now singleton set, simple, it's just a set that have only one element or only one member. That's known as singleton set. And we know the cardinality of this set is 1 because there is only one member in that set. Now finite and infinite sets. Simple. A set which is empty or consists of a defined number of elements is called finite sets. Like there is a place where we can stop in that set. Like example here we have 1, 2, 3, 4, 5. Finish. We stop till 5. That is a finite set. Number of men in the world, finite set. But if we set like the number of the stars in the universe, we don't know how many they are going on. That is infinite set. And as Q is the set of all rational number, if we're going to need to represent Q in a set of all rational number, it's impossible because numbers are going on, they're non-ending. So non-ending, the infinite is known as infinite sets, whereas the one that have like a definite number, they are known as finite sets. Now equal and equivalent sets. Okay, we have two sets. A and B are said to be equal. When are they said to be equal? If they have exactly the same elements. Okay, so we will write as A equals to B. Set A equals to B. Otherwise, it doesn't have the same elements. We say they are not equals to B. Where this is the same symbol, we write equal, but we'll cross that equal. Then at that time, we say it's not equal to B. Like for example, see here, set A is 1, 2, 3, 4, whereas set B is 3, 1, 4, 2. They are not in the same order, but they are the same elements. Here is 1, here so it's 1. Here we have 2, here we have 2, here we have 3, here is 3, here 4, here 4. So they have the same elements, but they're not in the same order. It doesn't matter the order here, but still they are known as equal sets. If they don't have the same elements, like here we don't have 4, then at that time we'll say they are not equal sets. That's for equal and unequal sets. Equal sets are sets that have the same elements. If here is ABC, the other set should also have ABC. Order doesn't matter, only the same elements need to be there. Equal. If they're not the same element that's there, then it's an equal set. Now for equivalent set, two sets A and B are said to be equivalent if they have the same number of elements. Here, the number of elements is the one that we needed. We don't care if it's A, if it's 1, if it's 3, we don't care. Just need the number. That's the cardinality number. Should be same. This is represented by this sign, but it's actually the same sign repeated twice under each other. Let me show you. Here. This is the symbol that we write for equivalent set. If they're non-equivalent, then the same symbol, and we're going to cross that with one line. That is an equivalent symbol. Here we said the number of the elements is the important thing. We don't need the cardinality of the number. Like here, for example, A, we have, in set A, we have small a, B, C, D, E. And in set B, we have 1, 3, 5, 7, 9. Here, how many numbers do we have? How many sets? I mean, how many elements do we have? 5. And here, how many elements do we have? 5. So they are equivalent. Order doesn't matter here, nor that the elements, if they are similar or not, it doesn't matter. We need only the cardinality number of the elements. Then they are equivalent. When we say it's equal, is that they should be the same elements should be present. But for equivalent, it's only the number of the elements that matter here. The order here doesn't matter. If they're same or not doesn't matter. Only the cardinality number matters here. Got it? Is everything clear?
Yes, I think so far everything is clear. Please keep going.
Do you have any doubts so I can like go back to it, or does anyone have any doubt?
Do anyone has any doubts? If yes, please unmute your mic and ask one by one.
Then I'll keep going.
Yeah, please.
Okay, now we're going to say about subsets. What are subsets? If every element of set A is also known as element of a set B, then A is called a subset of B, or A is contained in B. We write it as A is a subset of B. Like here, for example, we have set A is A, B, C. No, it's not this example, sorry. Here, in this example, we have set A is 1, 2, 3, 4. And set B is also 3, 1, 4, 2. We said the same elements in this set are present in the same elements in the other set. So this, we can say A is a subset of B, or B is a subset of A, because the same elements present in A are present in B. And it's represented by a C, a small c. Here, we say A is a subset of B. I'm sure I have picture written. Here, A is a subset of B. If the elements in A are not present, if the elements in B are not present in A, then we say that A is not a subset of B. The same C, but we're just gonna cross it, like how we did with the previous ones. That is a subset. Okay, so what is a superset? let A and B be two sets. If A is a subset of B and A, so this is not equal to, okay, it's not equal to B, then we say A is called a proper set of B and B is called a superset. Okay, I'm gonna explain for that. Okay, like here we have set A is 1, 2, 3, and set B is 1, 2, 3, 4. We see here set A, it have only 1, 2, 3. Set B, we have it till 4. So we say set A is a proper set of set B. Proper set should not have the same elements of set B. Okay, in proper set we need only one, we need all at least one set. Okay, at least one set that's not present in set B, then we call it a proper set. If we have all the sets in A, if set A is 1, 2, 3, 4 and set B is also 1, 2, 3, 4, then that set's known as improper set. Do you know first what is the sets? What are the subsets? Like for example, let's write an example here.
Is there anything you need assistance
here.
with? Okay.
No, it's okay here. Like here, yeah. We have set A. Okay, we have X. Let X equals to AB. Now we need to write all the subsets of set X. All the subsets will be first, this is a null set, okay? Which is like a circle and it's crossed.
Hey, we are only still seeing your Adobe file, I think.
Oh,
PDF
okay,
file.
it's not the share. Oh yeah, I
Yeah.
didn't change.
Yeah, okay.
Yeah, okay, now you can see.
Mhm.
Yeah, here. Now let X equals to set AB. Here, I forgot to add a comma. Okay. Okay, you can see now.
Yeah, we can see his screen. Yeah.
Yeah, okay. Here, for example, now we need to write the subsets of this set X. We have set X, it have the elements A and B. Now we need to write all the subsets of this set. All the subset will be, the first set will be null set, always should be a null set. You know how the symbol for a null set, it's like a circle and it's just crossed on it. It's not like an I decided, no, it's crossed, okay? That will be the first element. The second element will be the first one, set A alone, then set B alone, then set AB. Now these four elements are all the subsets of set X. Okay, in these elements here, null set A and B, all of them are proper sets. Okay, whereas set A and B is improper set. Improper set should not have the same elements of the set itself. Okay, here A can be a proper set, null set can be a proper set, B can be a proper set, but A and B together, they can't be a proper set. They are improper because they're the same elements of the set X. Got it?
Yeah, I would interrupt you just a little bit. I think you missed
Okay,
here
no
one
problem.
thing.
Okay.
Proper subset and improper subset, like this part here. Can you see? So here, A, B is a proper set. I think instead of that, you want to say proper subset and improper subset.
Yeah, on proper and
Right.
improper subsets.
Okay,
Yeah,
and can you
they're
please tell me what
subsets.
is this OL? I did not understood this one.
Yeah, that is the null set. You know the symbol for the
Okay,
null set.
you are
It's,
trying to use the phi sign, right?
yeah, that's one. But
Okay,
I can't get it here. That's
I
why.
will just WhatsApp you the phi sign because lots of people will get confused, and you can just add it here in 1 minute. Okay.
How? But the thing
Until then,
I'm opening it from my laptop. That's why. Can you share
okay,
it?
okay. One thing can be done.
I'll show
Does your
you.
laptop has WhatsApp?
No, it doesn't. I'll show you the symbol for the null set.
Yeah. Okay. So please just tell everyone that what this OL is, so that they know, because even I was.
Yeah, this is the symbol for oil. Okay, it's a null set. Can you see it?
Yeah, this is phi.
That is what I mean. Yeah, this is what's oil. It's there. It's a null set.
You can actually copy from here also. You just need to right click on it.
I tried, but it doesn't work.
That is there. Yeah, copy, and then you just go on Word. Yeah, is it? Are you able to paste it? Right click.
Yeah, see, it's come like that. It doesn't work.
Okay. All right. Okay, let it go. I think everyone can understand what this is.
Okay.
Okay, please go ahead.
So this is a null set. So this is how we write the subsets of an element. And the subset of the elements, we have proper set and improper set. Proper sets are just any set that is not the same set itself. Improper set is the same set itself that we have written as a subset. Yeah. Now properties of a subset. We're going to write the properties of a subset. If A equals to B and A is a subset of B, then B is a subset of A. This C is like how we write for a subset. It's C, right? We know if element A is equals to element B, like we said here. Element is A is 1, 2, 3, 4. And element, and I mean, set A are 1, 2, 3, 4, and set B is 3, 1, 4, 2. Both are equal. Both have the same sets, then equal sets. So if they're equal sets, we can say set A is a subset of B, and set B is a subset of A. That's the first property.
Okay, one thing, everyone, this because we are using free Zoom, okay, so our meeting time is limited to 40 minutes. So after 9 minutes and 30 seconds, the meeting will end automatically, but I will restart it just the same moment and just join from there only, okay, in case it ends in 9 minutes. So then she will continue after that.
It will end now?
No, like 9 minutes later, the meeting will end automatically because.
Okay, I can't complete by then. Then the next meeting will just clear the doubts.
Yeah, that's also good. Okay.
Okay.
In now the next 20 minutes part, you can clear doubts, right?
Yeah, okay. Now properties, the second property of set is that set A is the element of set A itself, like we have here. Let's just take set A is 1, 2, 3, 4, and we have the same set again repeated 1, 2, 3, 4. It's just same like we said in the first one. Set A is element of set A, and set A again is element of set A. So they are set for each other. I guess I said that correct. If I said it wrong, please clear me. That every set can be derived from itself. Okay, and like we said before, this is the null set. Oil is the null set, where this is just a circle and crossed by one line. It's a null set. It's a subset of every set. We said whenever we start writing a subset of any set, we need to start with the null set, like you said here. First, we need to start with the null set, then we can write all the other sets of that, subsets of that set. It's a subset. Okay, and if A is a subset of B and A, this means not equals to B, then we write A is element of B, just like how we said, this is the same thing, like we said improper and improper sets. Like here, for example, we have set A is 1, 2, 3, 4, 5, and 2, 3 is proper set because it just took two elements from this set. So it's a proper set. And what is a superset? Yeah, this is known as a superset. The elements that we take that are subsets of that element, they are known as a superset. Like here, the set is A. This is the subset of it, which is also known as superset. Okay. Here, if we have, yeah, it's just, this one is just to show us how's that, like, how do we know the number of the proper and improper set? Okay. The number of proper sets is always, but we have cardinality of A is equals to n. Just give it as n number. Then the number of proper sets will be 2 raised to n minus 1. Here I can't write it again, so I'll show you how actually it is shown. Yeah, here, like this. 2 raised to n. It's not raised to 2. Okay, 2 raised to n. This is the number of proper sets. If we need to find the number of proper sets, we write as 2 raised to n. N is the number cardinality of that set. Okay, like we have set A here, it have 1, 2, 3, 4, 5. Okay, we need to know. So there are 4 elements. So n here will be as 4. So if we need to know the number of proper sets, we write as 2 raised to n. That's 2 raised to 4. That will be 8, I guess. It will be 8. Yeah, I guess it will be 8. So that's the number of proper set. It should be improper. Yeah. Sorry. Wait, the number of proper sets, that 2 raised to n minus 1. Sorry, it's 2 raised to n minus 1. The number of proper sets. If we need to know the
If
number
you
of
want,
proper sets,
Husna,
we
if you
write
want
as,
for 2 minutes, I can share my screen and show what you're trying to do here. Can
okay,
should
no
I do
problem.
that? Then you would
Yeah,
be able to explain better. Okay, just 1 second. Okay, so what she is trying to say is, so let's say there is a set A. Okay, it has 2 elements, A and B. So modulus A, that is its cardinality. That's what it's called, right? Cardinality.
Yeah, cardinality is 2.
Okay, is 2. So the number of proper sets it can have is 2 minus
raised to n minus 1.
Yeah. 1
2
second.
raised to.
I'll just do that. 1 second, please.
Mm.
2 raised to 2.
Are you writing now?
Yeah. Are you seeing my screen, everyone?
No.
You're not seeing my
I'm
screen?
seeing only my screen. No, I can only see my screen. But not yours.
Okay. 1 second. I'm sharing my screen. Is my screen visible now?
No, not yet.
Is it visible? No, it's not visible.
No, it's not visible.
Okay.
Not visible.
Just 1 second. 1 second. It will be visible. Reclaim host. Yeah, I think now you will be able to see my screen. Is my screen visible now? It is visible?
No. Still no.
Still not visible?
Yes,
Not
not
supposed to
visible.
happen. Husna, can you unshare your screen for a moment? Hello?
Stop share. Okay.
Yeah.
Yes, now okay, now share.
Yeah.
Now, okay, now they can see.
Yes, now you're.
Okay, so basically what she is saying is that this is a set A, okay, it has 2 elements A, B, and cardinality of that set is how much? 2. So
2.
the number of proper subsets it can have is 2 raised to the power 2 minus 1. Okay, so we'll just see that 2 minus 1, that is equal to 2 to the power 1 equal to 2. That means we can only have 2 proper sets here. So the those 2 sets are this. One is this, and another is this. And the improper set, that is
A, B
itself. So which set is called improper set? I think some people ask that. Any subset which has the same elements, the same number elements, of that is called an improper set. Subset, sorry. Okay, Husna, now I'm unsharing my screen. You can go ahead. Just a second. How do I stop it? Participants. Okay, you are host now. And pause share. Okay, you are host now. You can share your screen, I think.
Yeah, okay. Can you see now?
Yeah, we are seeing your screen
Yeah.
now.
Okay. That's all for proper and improper set. Now we have is power set. What is power set? Power set is collection of all the subsets of set A. Okay. How we write power set? We write is P. P of A. They are all P of A is the power set of set A. Okay. Like for example, we have here A. Set A we have as 1, 2. Now we're gonna write the subsets. The power set just the subsets of that element. This is as null set. Okay, that OL. Okay, null set. We have 1, we have 2, we have 1. All this is known as power set, the power set of the set A. Okay. Okay, we should have the power set. We said what is power set? It's just the same subsets. We write it as power set. We write it as P of A. Okay, P of A. So what are the properties of a power set? Okay, we have in P of A, that's power of A, every element is a set. You know, this all of this element can be represented by itself. Null set can be a set by itself, 1 can be a set by itself, 2 can be a set by itself, 1 and 2, you know, it's just the set itself. Okay, that's the first property. The second property is that if cardinality of A is equals to N, it's just the same thing that which we said before, the number of sets, proper and improper sets. How can we find the number of proper and improper sets that I've been shown just now? It's just the same thing.
Hey, turn off your mic. Turn off your mic, please. I think I'll just say which one is it.
Okay. Now last we have is the universal set. Okay, a set which is superset of every set. It's known as universal set. It's represented by the letter U, capital U. Okay. For example, we have set U is 1, 2, A, X, Y. And set X is X and Y. Set A, that's capital A is small a. And set B is 1 and 2. Now we just only need to take the subset of this set U. We need just to take the subset of this set U. They will be the same. They will be 1, 2. They will be A. They will be X and Y. It's the same as we have in set X, A, and B. So the universal set of U is the same. 1, A, 2, A, X, and Y. Got it? Did I miss anything?
No.
I guess I have a kind of doubt in this thing.
Which one?
In this universal set.
In this universal set, set A is A, set B is 1, 2, and okay, I'll just see it. A set which is a superset of every set. It is a set which contains every set that is considered its subset. Let U equal to X equal to XY, A equal to A. Now you have covered everything. It's fine.
Okay, it will be more clear now when we do the examples and exercise. It will be more clear how come
Yes.
universal set.
So basically, she's trying to say if we have two. Okay, someone is saying Hafsha Rafi. Can you please explain again? Just explain again, Husna. Okay.
I think, sorry, I'm myself not sure how about it. So I don't want
Okay,
to give you the wrong
so I will just
information.
go
I
ahead
would have doubts
and
only.
okay, I will just clear this for everyone. Okay. So
Okay, no problem.
a set which is a superset of every set. Let's say you have 3 sets. Okay. You have 5 apples, you have 10 bananas, and you have, let's say, 2 biscuit packets. Okay. Now, if you take all of that and put all of that in a basket, so now you have a, a complete basket. Like that is like
Collection
a
of all
superset.
of that, yeah.
Collection of all of that. Okay.
Universal set.
Just the same way, Husna has made 3 sets here. Set 1 is A. Okay. Set 1 is A, and the A has one element. That element is small a. Okay. Set 2 is B. B has two elements, 1 and 2. These are the elements. And there is a there
Set
is
X.
another set, that is X. Okay. So X is X. X has two elements. Those are XY. So now if we combine all these sets, we get to this universal set, that is U. Okay. Now, just 2 minutes ago, we learned something, that what is a subset? A subset is like the elements of a subset belongs to the main set. Okay. So now these are three different sets, and these are like all of them have elements which belong to this main set, this universal set. Okay. This universal set is U. So all these sets, actually more subsets are possible, but she has shown three subsets here. Okay. That means these sets belong to the universal set U. Is it clear to everyone? Because see, set A, it has one element, that is A. That element is present in universal set U. Okay. Then there is set B, it has two elements, 1 and 2. That is also present in this universal set 1, 1, 2 is present here. Okay, in the set U. Same way X. So all, okay, is it clear now?
It's like see here we have U. Okay, let's just take U. Okay, it's 1, 2, A, X, and Y. Okay, if you only write the subset of only that elements, those are going to be the subset. Without this X and Y, I'll delete this. Okay.
Turn off your mic. People, just someone is with watching TV. Please turn off your mic. Akshay, turn off your mic.
Okay.
Yeah, go ahead.
Like what he's trying to say is that here we have set U, we have it 1, 2, A, X, and Y. If we wrote the subsets of only this set, it can be X, Y, A, 1, and 2. We can make it like more. We can write, wait, I will write it here, all the elements of set U, all the subsets of set U. All the elements. Okay, now let's write the subsets of this element. First subset we have should write is a null set, like we said. First is a null set. Okay. Then we have 1. Then we have 2. Then we have small a. Then we have small x. Then we have small y. Okay, we can then write 1 and 2. Actually, how we should write a subset? They'll be too long. They won't be short. This is here I show in a short example, but this is how the whole will be. Then we write 1, 1 and a, small a. Then we write 1 and small x. Then we write 1 and y. Now we go to 2. 2 2 and 1. Then we have 2 and a. Then we have 2 and x. Okay, we finished to now go to a.
Okay, Aisha has mentioned the universal set is represented by square, rectangle braces. So can you please check if that's true?
I'm not sure. It is just represented by U.
What?
Universal set is only represented by capital U.
Yeah, okay, no, you are right. Please go ahead.
Where we stop? X1, X2, Xa. No.
We will have a total of 16 elements, subsets, 2 to the power of n minus 1. Now n is 5 here, cardinality. So total 16. Just count if we have 16 yet. 1, 2,
Okay,
3.
I'll finish now.
Okay, I'll just check.
I think it's 2 raised to power n.
2 raised to the power n minus 2 raised to the n minus 1.
N minus 1 is for
N minus
proper.
1 for improper. I
Not for
think.
proper.
No, actually it's going
Improper
to.
is only one set.
Yeah, right. One, two.
Okay, those are, it still keep going on because this
Okay,
is
I
only
will
two elements. Now we need to take two elements.
actually one mistake you have done here. Okay, we will only have 16 of this. Now what you have done is, let's say the subset number in the second line, the fourth subset, it is 2 and y, and then again in the third line, the third subset is y and 2. Now y and 2 are the same as 2 and
You
y.
mean there should be no repetition? Yeah.
Yeah. That's why you are getting confused that what
Yeah.
else.
Yeah, but first we need to write it like that. Then we can, cancel all the repeated ones, I guess.
Yeah, okay, that's also you can do. Basically, you need 16 of this. There will be total 16 subsets here in the possible combinations.
Because still, if you keep going on now, and if you take three elements.
You don't need to repeat.
So
Actually, if okay, someone is saying something.
Yeah, so if you write a 1 comma a or a comma 1, I mean, these are the two one in the same thing, right? Either you write 1a or a1.
Yeah,
right?
I saw example like, yeah, they will be writing it, they will keep
she's
repeating it, and they're saying, yeah, it's a subset.
trying to show us like in what all manners it can be represented, like in what all possibilities it can be shown. I think that's what Husna is trying to do.
But
Yeah,
then
this
it is not a subset. It is the same thing, one in the same thing, right? It is not a different subset.
Yeah, it is the same set. Of course, this is the same subset.
So then it's wrong, right?
No, wait. Look, I saw this. That's so. What I also have a doubt about. It's like in some places where I saw that they will write it without repetition. In other places, they keep repeating it. Like A1 and 1A, they're saying it's different. And in some
No,
places, they're saying,
actually,
no, they're not
I will
different.
just clarify a little bit. What you have done here, it's right in one way. It's right in that sense that you have shown all the ways the subsets can be represented, because you can also write the subset as A2 and 2A. Like first element is A, second element is 2, or first element is 2, second is A. Okay. But when we want the list of subsets, total subsets,
yeah, then we don't repeat.
Then only 16, because right now you are trying to give us a list of 16. So in this case, there should not be repetition, so that it's easier for everyone to understand, because people will not understand otherwise, like what are these many things. Okay. But yeah, your point of
My question is, what is U represented here in the last line? What represents U in the last line? No, not in the last. Here, U equal to U. You have written this. I mean, what is U here?
Use the universal set.
I think this is incorrect, because inverted set is a collection of all elements, not
Sorry, you.
collection of subsets.
Basically,
I
Husna,
know.
just
I'm here. Yeah, here. This is not the universal set. Here,
yeah, she
just
is
the
just trying to
subsets
show
only.
that.
I'm just trying to show the subset,
Yeah,
not the universal set.
you should write it like a subsets of you, like
Yeah.
P of
yeah.
U. Husna, you just need to
Mm,
do this much, right? No, no, not. Yeah, yeah, that's fine also.
mm.
Subsets of U. Okay.
Okay.
Yeah, now it's fine, I think.
Mm. Okay. Any doubt?
Now you just cancel the repeated ones so that we have 16 only. Okay.
The repeated ones.
I will tell you which one is repeated. First of all, 1A,
Yeah. Here. Yeah. This
it's
one.
A1. Yeah, cancel that. Okay, done. Then we have 1x, x1, I think. One, yeah, cancel it. Now we have 1y, y1.
Mm.
Okay. Next we have 2-1 is fine. Oh yeah, 2-1 also.
2x.
Second line,
2x x2.
x2, right? Please cancel. Then we have second line, first one, 2-1. Because we have 1, 2 above.
Yeah.
Cancel this. Okay. So I think A2 is fine. Okay, now write the next subset. It is 1, 2A.
Yeah. No, 3 elements.
1, 2A. Next is going to be 1, 2x. Next is going to be 1, 2,
1, 2
y.
y.
Yeah. Okay. Next, right?
Then it will be
1, 2.
axy.
Yeah, axy also there. But if we go in a sequence, then we will not get
Yeah.
confused.
Yeah. Okay.
Okay.
First one now 2.
1, 1, 2. No, they will be less than 16. Just a moment, please.
Yeah. And we need to cancel other stuff like that.
Yeah, I think there are more that we need to cancel. Okay, I will tell you
No,
which
1,
one.
2 finished, right?
No, not finished. I will tell you which one to cancel. Second line, second last. YA, cancel that.
Y.
Okay. 5, 1, 2, AX, Y, 1, 2, 1x, 1y, 2a, 2x, AX. Yeah. So so far how many we have got here? 1, 2. I think something is. Okay, sorry. We made one mistake. Yes, you are doing fine. The formula for number of subset is 2 to the power of n minus 1, not n minus 1. It's going to be 2 to the power n minus 1. So total we will have, we have like 5 elements. So 2 to the power n, 2 to the power 5, 32 minus 1, 31. So there are going to be 31 subsets here. Yeah, please go ahead, write others also. Just press control YY, you will get the previous ones that you had written. Or just now 1 to AX. Next subset 1 to AX.
1 to A. Alright.
AX. Yeah. Next 1 to AY. Now, okay, yeah. Or I think, has everyone understood how it works? We don't have to write all of it. Has everyone understood the idea that how it works? Okay, then you can just, yeah, someone said it right. You can just put dot 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 now next to it. We don't need all of them. So basically, subset is that any set which has element from the main set, that is a subset.
Itself, yeah.
SWT. What is SWT? Okay, in 3 minutes the session ends for maths class. Anyone has any questions they would like to ask?
Without
If any questions, now is the time to unmute your mic and ask one by one. If there is any part you have not understood, you can ask that as well. Please guys, if you give feedback, then only it will be easier for everyone and for you also.
Yeah.
It will be useful.
I
Yeah,
think
yeah,
we
don't
should
do that.
take
Don't write on the screen. Okay, please, please don't do that. You were doing that yesterday also, and it really gave me trouble then like seeing the screen.
Can you repeat
I think we
power
should take
set?
a smaller example, like a set of 2 elements, and then write the improper
Yeah.
set, improper
Okay,
subset,
I
and
write.
That is right.
Okay. Like we have set A. It's 1 and 2. Okay. Now first to write the subsets of that element of set A. It will be first a null set. It will be 1. It should be 2. It should be 1, 2. Okay. We have set A 1 and 2. Okay, set A is 1 and 2. We wrote the subset of set A. Null set 1, 2, and 1 and 2. Okay.
But
Null
according
set,
to the formula, it should be 2 and minus 1. So it should be like 3. And there are
that's
4.
yeah, I'm coming here. Null set 1 and 2 is the number of proper set. Okay, that's why it's set 3. Those are the proper set. Okay. And 1 and 2 is the improper set. What's improper set? It's the same set itself. That is improper set.
Okay,
Got
so
it?
there was, yeah, in between session, you said that there is a formula which was 2 raised to power n. What does that represent? 2 raised to power n.
Yeah, 2 raised to power n represent the number of sets. Only the number of sets.
Set
This
elements.
dimension.
N
Yeah,
is the
set
number
elements.
of set elements. Like
Not
the
the
set
proper or
A has,
improper. No, both of them.
yeah, A
Okay.
has 2 elements. So N is that number.
All right, got it. Thanks.
And Husna, if you can just give me your screen for 2 minutes, I will just may clarify it better so that,
Okay.
okay.
Yeah.
All
yeah.
right. Just 1 second. First, I'll just copy the phi symbol also because some people might not have been, they might have been confused about that. Okay. I don't know if it's going to work in Word. I'll just still check. Anyways. So where is Word? There you are. Okay. So now the formula we read for proper subsets, that is, just 1 second. Okay. So let's say we have a set, it's called A. Okay. A is a set, and let's say it has n elements. Okay. Whatever the number, it doesn't matter how many elements. So the formula says that A is always going to have how many proper subsets? The formula is 2 to the power n and then minus 1. That is the number of proper subsets. Is that this much is clear to everyone?
Yes.
Okay, so I will now give an example. Okay, let's say A is equal to 1, 2, a very simple example, 3. Okay, there are 3 elements. So according to the formula, number of element or the cardinality, number of element is also known as the cardinality of the set. And what is the formula to write that? Sorry, we denote it like
Symbol.
this in modulus. Modulus of A is equal to how much? 3.
3.
That is number of elements. So now if we put that in the formula, 2 to the power 3 minus 1 equal to 7. So basically this set A is going to have 7 proper subsets. So let's start. Let's see one by one. Okay, subsets of A. Total subsets, that's 8 because 1 is improper also. So we are just considering the proper ones here. So first we have 5. Okay, this is the empty set. That means it has no element. Now this is also considered when we write any set. Okay, first is 5, then next is 1, next is 2, okay. So now anyone, can you count the number of subsets we have written here?
Yes, 7.
It's 7. One question, can anyone add any more subset here? Is it possible to add any more subset?
Yes.
No. Any proper subset, is any more proper subset is possible here?
No, we can't add.
We can't add because now we have all the proper subsets, because we have now 5 is also counted here, the empty set. That means this set has no elements, so this also belongs to here. Okay, so now we have how many proper subsets?
7.
Is it 7? Is it clear to everyone, or now should I explain what we have done here? Nobody says anything. Okay, in the chat they are saying, I think the same set is also, yeah, Husnia, you mentioned something that the same set is also, but now I told you, we are only considering the proper ones. Okay, so I will just add that one also, so for convenience, so people can understand. Now we have 7 proper and 1 improper set, and that is exactly the same set. The set itself, yes, perfectly said. The set itself is the improper set. Okay, now one thing I would like to add, that is P of A. What was the definition for P of something, Husna? I think it is the collection of all subsets, right?
Yes, collection
Okay.
of all subsets.
Yeah, so the collection of all subsets, that is this, for everyone
Even the
to
set
understand.
itself. Even
The set
improper.
itself, right?
Yeah.
Okay. Okay, so see, everyone can see here now this P of A, that is the collection of all the subsets of A, and that has how many elements? The total number of set
8.
is 2 to the power n. Okay, that is the total number of set, and the total number of proper subsets. that is this. Okay, I think it will be clear for everyone now. And 1 second. Okay, so yeah, I will just start from here. So we have a set A. A has 3 elements. So the cardinality of A is how much? 3. Total number of subsets possible, it's 2 to the power 3. 2 to the power the cardinality. That is, it also we have also included the improper set in this total list. Now total number of proper subset is how much? That is the total number of subset possible minus that one improper set. So that is total number of proper subset is 7. So we have written here the proper subsets, that is these 7 are the proper subsets. Okay, and one of them is improper subset. The last one is total number of collection of all the subsets which has both proper and improper, and it is how much? It is equal to, it's always going to be equal to this one, 8. Okay, 2 to the power 3. So we have 8 of them here. I think it's clear now for everyone.
Yeah, it's clear.
Yeah.
Okay, does anyone has any doubts? Because now I will be ending the session. We have after 20 minutes we have our computer session also. C, programming in C. And actually I think we all should give our feedback to Husna, because I am actually surprised that she took the entire hour without stopping or without any confusions or anything. Like, I really felt it. I'm very inspired by her, because I
Thank you very
myself,
much.
when I started taking classes for the first day or second day, I was very nervous, and I was dabbling here and there again and again. I was getting little bit distracted. Okay, but she
No,
has
you
done
did really good job.
she has done very amazing. So please, everyone, congratulate her. This was her first session taken for us. Okay, share your feedback also.
Thank you very much.
Everyone, please, you can turn on your mic and say your piece, anything you want to say.
Yeah, they're writing the chats.
Okay, yeah, okay, you are writing in chats. Okay. All right,
Thanks
then.
for taking the initiative. It was very helpful.
Thank you.
No, we the real work people who need to be thanks are those who are going to attend and those who are going to teach. So we have to thank all of us for being here, because we are
Yeah,
doing it for
especially you.
ourselves. We need to thank
Yeah,
all of
especially
us.
you're the one organizing everything. Thank you very much.
No, that is
Keep on
one
going.
thing, because anything needs someone to start, but we all need to thank all of us. We all have made this possible. Okay, so each and
Yeah, thanks
everyone
for
who has
everything.
joined here, each and everyone who is going to conduct classes, we should be thankful to all of them. Thank you. Okay, I'm ending this session now. We will start another session in 20 minutes. I have to go home. It will take my maximum of 20 minutes, and then I will start the programming C from where we have left yesterday.